Greetings, everybody. So here we are, day two really of talking about factoring and why factoring is useful. And so today we're going to take a look at these polynomial functions and finding solutions from them. So solving them. As you know, Algebra 2, we do a lot of graphing and a lot of solving. And so today is the solving portion of what we're working on. So please get this heading in your notes. We're going to be factoring polynomials to find real number solutions. So in other words, we're going to be factoring completely and then solving. You're going to need a calculator, your factoring tools, which may be that foldable, as well as your difference of cubes, sum of cubes, and your notes to take some examples down in today. So the key question we're going to look at is, how do I use factoring as a way to find solutions to polynomial equations or functions? Remember your factoring tools that you have in your little foldable we just mentioned: greatest common factor, grouping, AC method, difference of squares, difference or sum of cubes. Whatever it takes, our goal is to factor it down so that we can solve it. So here's the first one you need to write in your notes. It is 2x to the fifth minus 18x to the third equals 0. So if we're going to factor this guy to help us find the solutions, I'm noticing that both of these have a greatest common factor that can be divided out of them. If I want to, and I do, I'm going to take out the greatest common factor, 2x to the third, because both of those terms can be divided by that. If I do that, well, what's left? This first part here would become x squared, because I had 5 x's there. X to the fifth means x times x times x times x times x, and I chose to take out 3 of them. And minus sign, 18 divided by 2 is 9, and no x to the thirds there because I've taken those out. So far we're here. Equals 0 is still hanging out on the other side. That's going to come in handy when we go ahead and solve. Now I'm looking at what I've created here inside these parentheses, and I'm still noticing that this is a difference of perfect squares. That means that 9 is a perfect square number, and x squared is also square rootable. So that means that he factors down into x plus 3 and x minus 3 equals 0, still hanging out here, and this 2x to the third is still going to drop down next to those guys. So once I feel that I've broke this thing apart, or I've done all the factoring here, I then go ahead and solve them. So I try to find the solutions. If you remember, one of the things we've been talking about is making sure that we can solve from each factor. So I'm going to take this x to the minus 3 equals 0 here, set him equal to that 0, and solve him, and x is 3. Then if I take the next factor here, x plus 3, and put the equals 0 after him, x equals negative 3. And last but not least, 2x to the third equals 0. I need to divide by 2 to get the x alone. X to the third equals 0. I cube root x to the third. What number taken to the third power makes 0? Just 0. So here are the real solutions that I'm looking at here: 0, negative 3, and 3. This is very similar to what we did when we solved quadratics by factoring, except you might have more terms now. You might have more pieces, more solutions. Okay, let's look at a second one here. I'm noticing that this one has 4 terms, so I'm going to go ahead and place this one into the 4 squares so I can factor by grouping. Okay, and now once he's placed into those 4 boxes, we do the grouping method of factoring. Going to divide something out there. Going to divide a negative 16 can be divided out of both of those pieces, negative 16 and 48. Up this column here, I'm going to divide an x out, and this way I can divide a negative 3 out of both of those pieces. So my factors become x minus 3 and x squared minus 16. So far, so good. Now I'm still noticing that I have an x squared minus 16, and I remember that 16 is a perfect square number. So because this is a difference of perfect squares, I'm going to continue factoring that x minus 16 into 2 more pieces, x plus 4 and x minus 4. And again, there was an equals 0 way up here before we started factoring as a reminder that we need to go ahead and solve these. We're trying to find where each piece equals 0. So x minus 3 equals 0, x plus 4 equals 0, x minus 4 equals 0, and if we go ahead and solve each of those, we get x equals 3, x equals negative 4, and x equals 4. So 3 solutions there on this problem. Let's try a third one here. We are going to factor completely and solve that word should be solved. X to the third minus 4x squared minus 12x equals 0. So if I look at this, I see it's a trinomial. I'm also noticing that all of those pieces have x's here. So I think I'm going to take out a greatest common factor of x, which would leave me with x squared minus 4x minus 12. So I'm still noticing that even though I took out the x, I still have a trinomial in here that could probably be factored using the AC method. So I'm going to put a 1 in front here so I remind myself a times c is negative 12. What multiplies to make negative 12 and adds to make that negative 4 in the middle here? Negative 6, positive 2. So I'm going to go ahead and place this in the 4 squares, negative 6x, positive 2x, minus 12, and I'm going to factor it. I'm going to take out an x this way, 2 this way, x this way, negative 6 up and down there. So what I have for my factors here are x minus 6, x plus 2, and don't forget that we started this factoring process with an x that we took out. And we still have that handy dandy little equals 0 after it. Smiley face. And so now we go ahead and we take those pieces or those factors and set them each equal to 0. If I set the first piece equal to 0, that's pretty easy to solve because there's nothing I have to do. The next one here would lead me to a solution of positive 6. And this one would lead me to a solution of negative 2. So again, I have 3 solutions for this x to the third problem. Last but not least, here we go, 4th example, and then we're done. So we're going to factor completely and solve. When I look through these, I'm noticing these are this one's a little different than the others. 2x to the 5th plus 24x equals 14x to the 3rd. All the others had a handy dandy little 0 over there, and we want to get that same situation going on here. So I'm going to subtract that 14x to the 3rd away. And be careful where you place him on that other side. We want to keep this guy in standard form. So it's going to be 2x to the 5th minus 14x to the 3rd plus the 24x so that I can keep him in standard form. Now that he's written over there and everybody's hanging out on the same side, now we look to factor that. I notice that all of them can be divided by 2 and an x. So if I divide by 2 and an x for each term, it becomes x to the 4th minus 7x squared plus 12. Okay, so far so good. We've taken out a 2x, and now we are going to go ahead and take a look at what we have. I'm still noticing trinomial right here. Maybe AC method would be a good tool. So I'm going to take the a times the c. That's, again, a 12 here. What multiplies to make positive 12 and would add to make negative 7? How about negative 4 and negative 3? They would multiply to make positive 12 and add to make negative 7. So I'm going to go ahead and use that as some pieces that I can stick inside my 4 squares here. That is an x to the 4th on this problem at the beginning, 12 at the end. And negative 4, not just x though, you guys, x squareds were in the middle. So we need to have x squareds there. They need to make negative 7x squared. So now when we factor out common things here from each row and column, x squared, negative 3, x squared, negative 4. And now let's take a look at all the pieces that we have here. So I'd have x squared minus 3, x squared minus 4, and the 2x that I took out in the beginning. He comes down. So far, so good. Now let's look through here. 4 is a perfect square. X plus 2, x minus 2. But 3 is not a perfect square. So I'm just going to leave him as x squared minus 3. And 2x doesn't have any squares in it at all. So there we go, all the pieces. Now I need to solve each one. Okay, so if I set the 2x equal to 0, I get x just equals 0. And if I set this one equal to 0, I get x equals 2. x equals negative 2. Now careful on this x squared minus 3. If you do x squared minus 3 equals 0, you get x equals plus or minus square root of 3. Remember when we solve those? Don't forget that part. So my solutions that I have here are 5. 0 plus or minus square root of 3, negative 2, and positive 2. Lots of solutions on this one. Complicated polynomial. Okay, so this is what we're going to be looking at over the next few days. Thank you for watching and taking good notes.